program 1, experiment 1. So the question is design and develop a flowchart or algorithm to accept three coefficients A, B, C of a quadratic equation ax square plus bx plus c is equals to 0 and compute all possible roots. Implement the flowchart and algorithm in C and output the roots with appropriate messages. So this is a question. This is the program we have to execute. So for this, we should know what is a quadratic equation. So quadratic equation is ax square plus bx plus c. This is our quadratic equations. So the quadratic equation are calculated using this formula. This is the formula to calculate quadratic equation. So this thing is known as discriminant. So d is equals to b square minus 4ac. Then d, if d is lower than 0, then we'll get two real and distinct roots. And if d is equals to 0, we get real and equal roots. And if d is less than 0, that is negative, we get two complex roots. So to get real and distinct roots, d should be positive, and to get real and equal roots, d should be equal to 0. And for negative, d should be less than 0. So we'll start our code here. This is the preprocessor directive. And this we are using this include math.h library function for square root because in this program we'll do some calculations, so we need this library functions. Int min is the opening point of any program. So here, this thing we are declaring a variable set. So float A, B, C are the coefficients, and discriminant I told you only what is discriminant. So this is discriminant here, and root one and root two are for storing roots, and this is real part and imaginary part. So the first step is to take input from the user. So we'll this printf enter coefficients A, B, and C. So on the screen it will display this. Then we'll take input from the user using scanf function. Percentage F is format specifier for float, and we are using AND A, AND B, and AND C to store the address of this coefficients. The second step is to calculate the discriminant. So what is the formula for discriminant? It is b square minus 4ac. So b to b square minus 4 into a into c. This asterisk, this is known as asterisk. Then the third step is to check nature of roots. So I already told you the logic, how to check if d is positive, then it's real and distinct. If d is equals to 0, then real and equal roots. And if d is negative, then we have complex roots. So in step three, we'll check if d is greater than zero. If in case it is greater than zero, then they are real and distinct roots. So root one and root two. So if they are real and distinct, then we'll print roots are real and distinct. And this is percentage point two f. This means this is the format specifier for float, but for double precision. Like after decimal, we will have two values. So percentage point two f means after decimal, we have two places. Okay. This is for double precision. Then if this is not the case, then discriminant will be equal to 0, and that is real and equal roots. So root 1 and root 2 will be same. So minus b by 2a. Then we'll print this also. And if this is also not the case, then we have the x, that is complex roots. It will be negative, so minus b by 2a. And this is how we'll print it. And after that, we have written 0. Why we use written 0? Because of this int main. Because we are expecting a value in return. Uh, So if program is executed successfully, then we'll get 0. And if we have some error, then we'll get some non-zero value. Okay. So this was the code. Now we'll execute this in the compiler. And this is the flowchart of this. Start, enter coefficient, will discriminant. This is the flowchart. So let's now go and execute this program. So this is a program 2. So we are again given a quadratic equation, and we need to write a C program that takes input values for A, B, and C, then calculate the print route using formulas. So this is similar to the first program, but here basically it focuses on formula and implementation and computation. So let's recap the formula again. So uh, discriminant is equals to uh, b square minus 4ac. And then we have the roots. If d is greater than 0, then it is positive, so real and distinct roots. If d is equals to 0, then it is real and equal. And if d is less than 0, then it is complex root. So we'll come to code again. This is the preprocessor directive. This is the library function. So because we are going to find square root, so we need this library function. This is the opening point. Here we are declaring three coefficients A, B, and C float. And here we are declaring other variables. Discriminant. It's same like the previous program, so I will skip it fast. Uh, Here, we are taking input from the user. There are three coefficients. Discriminant. If discriminant is greater than 0, then we have real roots, real and distinct roots. We execute this, and if we have discriminant equals to 0, and in this whole case, we have real but equal, real and equal roots. And in this case, we have complex roots. And again, return 0 because if the program is executed successfully, then it will return 0. Okay. Why? Because we are using increment. So let's so let's move let's move to the execution of the program. Yeah. So let me connect my mouse. Wait just a second. So let's copy this code from here. I think we can copy. It will save our time basically. Command C. So basically the program will be same. So let's run this program out. Error. Oh, yeah. And the coefficients are this. So it's the 2, 3, and 5. So here are the roots. The roots are complex, so root 1 and root 2. Again, we'll take more time, then we'll move to the next one. 6, 8, 6, 8, and 9. Here are the roots. So now let's move to the other program. There is a third experiment or third program. The program is write a C program to relate two integers using equal to, greater than equal to, or less than with nested ifs and multiple ifs. Okay, so let's start it. So first, what we'll do, we'll take two integers as input, then we'll compare them using equal to, or greater than equal to, or less than. So we are going to use nested if and multiple structures to decide and print the relationship. So here's first code, and here I've taken the alternate version, which is using nested if. So first, let's see a code. Uh, this is preprocessor directive. This is the opening point of the function. Here we're declaring two numbers, number one, number two. So in step one, we'll take input from the user. So enter two integers, percentage v, percentage v. So number two and number two, number one, number two. So the first program we are writing is using multiple ifs. Okay. So in this, we write if, and if number one is equal to number two, then print number one is equal to number two. Else if number one is greater than number two, then print that number one is greater than number two. Or else number one is less than number two. So this is the simple program, very basic program. This is very basic using multiple if. Okay. Now coming to the nested if version. So here again same. Paper the directive. Opening point of the function, declaring two numbers, taking inputs from the user. So here in this case, number one is greater than equal to number two, then number one is equals to number two. Okay. Else print that number one is greater than number two, or else print number one is less than number two, and then return zero for intent. So I hope you understand this program. So now let's execute this program again. So we'll just copy the code because I've already written it here. So let's make this copy this code and yeah. So, so here again, people to the directive. Then this is the main function. Then we'll take input from the user here. Percentage G is format specifier for integer. Then we are using multiple if here. Okay. So now let's run our program. Error. Achha, wait. I have two written zero here. Now it will run. Enter two integers like the 3 and 5. 3 and no, 3 and no 5 and 6. 4 and 5. 4 is less than 5. Okay. Then this will take 7 and 3. 73. Wait. 73 and 856. And 73 is greater than 56. Okay. So this was our code using multiple if. Now let's see our code using nested ifs. So this is our code using nested if. Now let's run this code. 4 and 6. 4 is less than 6. Okay. So this was our code, both the code. Now we move towards the code. So this is experiment number 6. So in this we have to perform binary search. So basically what is binary search? Mm, so binary search is a fast searching algorithm. It only works on sorted array. Sorted arrays means your array should be either in ascending order or should be in descending order. It should be arranged. It should not be random, either in ascending order or either in descending order. So we have to first find the middle element of the array. And to find the middle element of the array, we have a formula that is first term plus last term, first term plus last term by 2. By this, we'll find the middle element. Okay. Then if the search value is equals to the middle element, then it is success. So we'll execute the program and exit. But if this is not the case, then we'll search the left half. And if we didn't found, no, if the search value is less than the middle element, let's suppose this is the middle element, first element and last element. If the value is less than the middle element, so we'll search on the left half. If the value is greater than the middle element, then we'll search on the right half. But if the value is equals to the middle element, then we'll exit the program by printing this. Okay. So we repeat this until the array becomes empty or we found an element. So this is the logic of the binary search. So now let's move towards the code. So first we are previous to the directive, then we are declaring some important variables. Then we are taking number of elements here, input from the user. Then this is for uh, sorting the numbers in like ascending or descending order. Then we have to enter the search or the key which we want to search in binary. For example, let's take 5. So we want to search number 5. So it will search 5 in the whole program. Okay. So in this case, in binary search, we use like the number of terms are 5. So we use indexes like 0 to 0 to n minus 1. So suppose number of terms are 5. So 0, 1, 2, 3, and 4. These are the indexes of the array. Okay. We take from 0 to n minus 1. If n is equals to 5, then 5 minus 1 is equals to 4. So 0, 1, 2, 3, and 4. This is how we take indexes. So we have to use this while condition here. And then the first thing is if the array is the middle element is equals to the search, then then the position is found, and we'll exit like break. We'll exit the program. But if the target is less than middle, then suppose this is middle, this is the first term, this is the last term. If the target is less than middle, then you have to search the left part. So for this, we use this formula, that is last is equals to middle minus one. So this last comes here. So we'll search this left part. And if the search is on the right side, so we have to plus this middle minus one. No, sorry. If the key we are searching is on the right side, then we have to do middle plus one. So we'll search it here. But if it is on the left side, then we have to search it here. So here it is the formula middle minus one. So this is the logic here using. And if it is not the case, then we'll do if condition first greater than last and percentage d, the element is not found in the array, and then return zero. So I'll explain this again nicely. First, we have middle element. This is the first element, last element. If the search is equals to the middle element, then we'll break the program and execute this. But if the key or the element we have to search is on the left side, then we'll use the formula middle minus one. Middle minus one. So here we'll search in this part. Okay. But if we have a key on the right side, then we'll use the formula middle plus one. So we'll search on this part. Okay. So this was the logic. Now let's execute this code in the compiler. And here is the flowchart of this. C start, then we have to input size and array. Then we have to input the search element which you want to search. Then C, middle plus first plus last by two, finding the middle element. Then C, uh, if it is greater than equal to search, then we'll use middle first equals to middle plus one. Then if not, then we'll search on the left side. So middle minus one, and the end of the program. So this was the flowchart. Now let's execute this program here. So wait. Now let's copy this code which I've already written to save some time. Yeah, run. So the number of elements. So I write 22, 33, 44, 55, 66, and 77. Okay. And the 22 integers in sorted order. Wait. Uh, First, you have to enter number of elements, like 5 elements. Okay. In sorted order. So I'll take 3, 4, 5, 6, 7. Okay. Enter. Now, if I want to search 5, this is the middle element. Okay. So it will give found at position 3. Okay. Now let's clear this, run it again. 5 elements again. 1, 2, 3, 4, and 5. Now if I want to search this like 4, it will get it responded at position 4. So this was our program. So this is our experiment 5. So it is write a C program to generate the Fibonacci series from a given number n. So this series is a sequence of numbers where each number is sum of preceding two numbers. Means 7 is sum of 6 and 5 preceding two numbers. Okay. So it starts with 0 and 1. So you can see f of 0 is 0, f of 1 is 1. So sum of two preceding numbers means n minus 1 and f of n minus 2. So now I think you have an idea what Fibonacci series is. So let's go towards the code. This is the preprocessor directive. This is the opening point of the code. So now, first, what we are doing is we are declaring we are declaring variables. So first, I int n, which means no, n means number of terms here, n means number of terms, like how many terms are we giving? And first means zero, and second means one. And next is to store the next number. This is for to store next number. And this I is the loop counter. Okay. So now first we'll take input from the user. How many numbers he wants, how many terms he wants. So this is for taking input from the user. Input will come from scanf. First it will print on the screen this thing. Then he'll enter the number of terms. Then print Fibonacci series. Then we have this loop for the series, that is I is equals to 0, I is less than n, and I plus plus population. So if n is less than equals to 1, then the first two terms are directly 0 and 1. Okay, this means loop will run n times, and this means that the first are 0 and first two terms. First term is 0 and second term is 1. But then else next is equals to first plus second. And the first term is 0, second term is 1, and from the third term will you go for next. Okay, that is first plus second. So this is what we are going to use. Then after that, we'll go for updation. That is first is equals to second and second is equals to next. Next means this thing. Then we'll enter the program and then we'll print every number, every term. Okay, and this is the flowchart for this program. So now let's go and execute this program. Let me connect my keyboard. So let's first copy this code. Mm, We can't see. So this is our code. Again, int n is number of terms. First term is 0, second term is 1, and next is first plus second, and I is the counter loop. So now we'll run the program. Enter number of terms. Enter number of terms. So like we are entering four terms, then this is the Fibonacci series for that. And if we are doing number of terms 7, then let's wait a minute. Wait, it's number of 5. Then this is the Fibonacci series. So now this program is done. Let's move to the sixth program. So now this is our seventh experiment. So basically, you have to perform basic functions like operations like addition and subtraction, but this time we have to use matrix operation. Okay. So what is a matrix? Matrix is basically a one common. Okay. So here in matrix we have matrix A. So this is the row and column. Okay. So basically this is the matrix. So you can see matrix. Okay. So let me first tell you concept that we are going to use in this matrix. That is matrix addition. So see, I is row, J is column. So matrix of A row column plus matrix of B row column, which gives C matrix. Okay. So this is how we do addition. In while doing subtraction, just you have to say change the sign. So this is how we subtract. And while transposing, what happens in transpose is row and column. Okay. So in this, the row become column and column become rows. So this is not a transpose. Like you can see here, I becomes J and J becomes I. So this is the only thing. Now let's move to the program. So here we are declaring variables here. Okay. Uh, Next is we have taken matrix. Where for transport differentiation sum, now we'll take input from the user that what is the first matrix, that is A. So let me explain this for loop for you one time. So this is the wait. This is the outer loop, that is for rows, and this is the inner loop, that is for columns. Okay. I run for rows, that is outer loop, and J runs for column, that is inner loop. So now we take input of the second matrix also, element of the second matrix, that is I again rows, and this is columns. This is rows and this is columns. So now matrix addition. So we have two matrix now, matrix A and matrix B. So we basically we'll do nothing, just add this. And in for some of matrices, we'll add this. In matrix subtraction, we'll subtract this, and for differential matrices, we'll do this. And for transpose, I already told you rows become column and column become rows. So this is the transpose of the matrix. And return zero for it successfully executing the program. So this is the basic simple code where I'll execute and explain it there a little bit. So basically the flowchart is start the program, input rows and columns, input two matrices, perform addition, subtraction, and transpose. Then display the result and end. So basically this is the flowchart, simple flowchart. Now let's run the code. So let me connect my keyboard here until here. So I've already written the code here. Let's just copy this and go towards the